Awesome. Hello, hello. I'm going to share my screen and also go to Facebook. Where are you? Live on Facebook. Oh, of course, it shares my screen though, so I'll just stop that for a minute. There we go. All right. Thanks to anyone who's hopping on with us. I see a couple of you have joined. Join us now. Page SciStarter. Okay, cool. While that goes live, thank you those of you who are joining us. Hello. Oh, awesome. One of our teachers was able to join this one. Hi, Summer. Or school connections anyway. Technically not a teacher, but actually you do step in for teaching sometimes. Hi, Facebook. Let me get rid of that for a minute so we can actually go and check out our slide deck. If you are seeing this on Facebook, just as an FYI, this is a webinar to talk about Ant Picnic, a citizen science project about ants and their dietary habits, and how they and how you can set up a science project to actually see what is the most common food that these ants will go to, depending on where you are in the world. So if you're interested, you can continue seeing this from Facebook, or you can join via the webinar on Zoom. Which we can send a link for in the comments as well. Oh, thank you, Summer. Summer just sent in a chat about that. You are very welcome. I'm happy to be here. For anyone who was with us last week, we had a very, very live version of SciStarter Live from the Seaside Conference 2023, and it was with me like making la 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 noises in the background as we transitioned from one person to the next. So it was very, very real, very raw. And it was wonderful. So I am going to go ahead and get us started then. I think we will hopefully find a few more people in our group over time. Awesome. Okay, so just quick introductions. My name is Emma. I am a program coordinator for SciStarter, and I just finished my graduate degree, my master's at ASU, which I was a SciStarter fellow at Arizona State University. So that's all done, and now I'm here again. Roland, if he was out for 2 seconds, so I'm just going to check if he's back again. Roland, do you want to introduce yourself? Yes.
Yes, thank you. I'm Roland, Quality Assurance Coordinator. I arrived back from the US a few hours ago, and I'm glad to be sharing the links with you guys as usual.
Excellent. And then Trevor's with us every once in a while to also host these, but he is out today. He actually just got married, so congratulations to Trevor. And I'm going to go ahead and pass it on to our guest speaker. Would you like to introduce yourself?
Yes. Hi. First of all, thanks for having me. So my name is Magdalena Sorger. I am a myrmecologist. I'm an ant expert. I started my career off in a very different place, though. I actually finished business school over here in Vienna, where I am right now, Vienna, Austria. I got my PhD in the US at NC State. And yeah, I focused on ants during that time. I worked at the North Carolina Museum of Natural Sciences, where I really got interested in citizen science, and we started like a big project, and part of that was to also develop the Ant Picnic project. A few years ago, I returned back to Austria, where I started a science communication business called Discover Ants, where I'm translating and developing the Ant Picnic project to reach more of the world with it.
That's awesome. Thank you for the context for that too. I'm excited to have more people able to participate in it. I did want to ask, actually, I forgot to mention, I just was curious what your PhD dissertation was about ants, like what part of ants that you focused on?
So I'm interested in islands and in island-like distributions. So I studied this in various parts of the world. So one of my projects was in Florida, and in Florida, you maybe know like the sand ridges in Florida, the Lake Wales Ridge, the Brooksville Ridge. There's several. They're slightly higher points. They're about 100 miles high. Like they're not very high. This is 100 miles. I think it's 100 feet. I'm getting confused with like European. They're not very high, but they mostly have orange orchards. But there's also some unique flora and fauna on them. And there's an ant species, a trapjaw ant species, that only occurs on those ridges. And there's one species that only occurs on 2 ridges. And so I studied them and I realized that those 2 populations on those 2 ridges are actually separate species. And then I had a separate project in Borneo where I studied also basically speciation on the population level almost. So I was interested if populations are different enough that they can actually be called different species along a mountain, like along a gradient, like a mountain gradient. And so if the populations at the top of the mountain are different than the ones on the bottom of the mountain. And also there, I found that what was different was actually different species. And then I found some weird jumping behavior in trapjaw ants that wasn't known. And then I had another project in Ethiopia where we also looked at island-like distributions of church forests, which are these island-like structures. And there we found an ant species that actually didn't care about that at all and makes super colonies. And it's also super interesting.
Wow. It's funny how much you can hear about ants and then be like, wait, what? We had a conversation before this call started for anyone that was about ants and how wild they are, because I had recently learned something that was just insane. So I'm really glad that you're here to answer any questions about how wild ants are. Did you have any of those species named after you by chance?
I have one species named after me. I'm so excited about that one. So I have one species named after me that I collected and my colleagues at the museum here in Vienna described. And so I was lucky that they actually wanted to use my name. And I have a bunch of species that I named, I guess collaboration. So that's fun too.
Any favorite names? If
I called my first ant. It's a Polyrachis. It's like a spiny ant. They're super cool ants. It was an ant from the Philippines. And I called it Pirata, like pirate ant.
Oh my gosh.
Because I thought that she was compared to the others. So she's like these bluish shimmery ants. And this new species, she was like a little greenish. And she looked really fierce. Like her spines were a little stouter than the others. And so I thought it was a very fitting name. And yeah. So
I'm writing that down. I'm going to look that up later. I'll send it in the follow-up email. Pirata ant.
Polyrachis. Pirata. It's a little hard to spell though, Polyrachis.
Oh no. Can you by chance type it in the chat while I go over the chat via or versus Q&A concept? That would be amazing. Okay, so on from ants for a moment here. Oh man, okay. Yeah, okay, that is oh yeah, and that's to hosts and panelists. So I'm gonna go ahead and send that to everyone just so they know. That is a difficult spelling. Wow. Awesome. So because we're a webinar, you can use the chat function. Feel free to react to the Polyrachis pirata term in the chat or introduce yourself. You can also use the Q&A. So if you have any specific questions about the ant picnic or citizen science as a whole or SciStarter, feel free to drop it in there and then I'll answer it for all of us instead of just in the chat. The chat's also nice for reaction. So if you have any ant stories you'd like to share, I'd love to hear them. Now, before we get started with anything else, I did want to go over a few polls. Roland will be dropping this one or launching this one about if you've ever participated in a citizen science project before, or I might do it. Oh, there we go. Yay. Thanks, Roland. If you've ever done a citizen science project before, we want to know. We would like to know. I see some of us have decided to not pay attention to the polls. Awesome. Well, we've got at least one newbie, which is great, and one not so newbie. Awesome. Cool. Alrighty. So we got a mixed bag of maybes from quite a few of you. Also, we'd like to know if you've ever been to one of these events before. So every week on Tuesdays, except for last week, which was on a Thursday, have you ever been to one of these live events before? A lot of no's. Sweet. Okay. Well, welcome. I'm excited to have you here. Cool. All right. And then lastly, we want to know what type of human you are. So are you a citizen scientist? Are you a student? Are you a parent? Are you a teacher? The actual poll looks a little bit different from the one online because we wanted to know the difference between if you were trying to be a citizen scientist or if you already are a citizen scientist. You are seasoned, you have done quite a few, etc. Or if you're students, researchers, bored person on the internet. No bored people today, which is great. Or bad. I don't know. I feel like this is a beneficial thing for the board people on the internet. Awesome. All right, and then I'm going to go through just some basics of citizen science and SciStarter, just so you can feel a little bit more comfortable with what we'll be talking about today. Citizen science, as our definition, is a collaboration between scientists and those of us who are curious, concerned, and motivated to make a difference. It's how people can make an impact on issues they care about and help science. So if you care dearly about ants like I do, then you will be doing Ant Picnic to have a better understanding of long-term information about ants, which we'll talk about today. And I'm not even being facetious, ants are really rad. Anyway, so this is our definition from SciStarter. So if you want more information, that has been dropped in the chat for you as well. SciStarter.org is a giant database. So the first thing you should do as someone who wants to be a citizen scientist or is looking to learn more about citizen science, first thing we can recommend for you is to actually join SciStarter.org as an account holder, because we are essentially a database of projects, which Project Finder is in our in the chat now. And we are also a support network, right? So we have a ton of resources available to different types of people or entities that'll help you get an even stronger foothold on citizen science. And that's what we exist for. So you can always reach out to us. In addition to becoming an account holder, or with becoming an account holder, you also have access to trainings that'll actually end in a certified badge that's personalized to you. And I have mine on my LinkedIn. They're very cool. My favorite is the building data literacy one. As a former 5th grade teacher, this would have been super helpful if I had known about it beforehand. So I always think back, I'm like, wish I had told them that or showed them that. Anyhow, we're going to move on to the actual project of today, which is Ant Picnic. So I'm going to turn it over to Magdalena and let her know how we can all participate. And I expect you to just give me like a next slide, a little comment, and I'll keep doing that for you. Before I turn it over there, I just wanted to show you all, if you are a SciStar.org account holder, you can also get credit for every time you participate in Ant Picnic. So if you go onto the affiliates page, you can see more helpful information. You can also go to the regular project page, which is what Roland just dropped into the chat as well. So both are helpful. And then you can also, or when you hit participate web at the bottom, or participate or view form on the regular project page, you will submit data on SciStarter. So it automatically just connects to your account, and therefore you get credit every single time. So pretty cool there. And that's all because of the affiliate program. So we try to make as many as possible affiliates. All right, Magdalena, I will stop talking so you can take it over for a while.
All right, thank you. Okay, so first of all, I want to talk a little bit about the research team and how Ant Picnic actually originated. And so I was talking about North Carolina State University, which is where I got my PhD, and I got it in Rob Dunn's lab. And this is also where the project originated. It was actually a continuation of another project that was called School of Ants. And School of Ants was a project to basically just find out what ants are where. And for maybe you guys know how you can bait ants the best. And it's usually cookie crumbs or something like that. So among ant biologists, it's like a secret, we use pecan sandies, which you probably all know, because those are and I don't have pecan sandies here because I'm not in the US, but you can get them usually at every store. Because Emma, I see from your face that you don't know what they are.
I don't know. Is it an East Coast thing? I'm from the West Coast. I wonder if
that's a very good question. I thought you had them everywhere, but now I'm not sure anymore. But yeah, among ant biologists, pecan sandies are like the go-to ant bait, so because they're kind of fat, kind of oily, and they have like the nuts in them and then the sugar and the cookies, so they're like perfect. So that's what they used for School of Ants, to bait ants, just to know, what ants are where. So again, the goal was to study ant distribution. This project was led by Dr. Andrea Lucky. She's currently at the University of Florida. And that project was really successful because people collected, so they had like little tubes, they put the pecan sand, so they received the tubes, there were the cookies in there, they put them on the ground on a grassy area and on a paved area. And then the ants went in there, they closed the lid, they closed the tubes, and then they sent them back to NC State for identification. And with that project, we were actually able to expand the distribution of one ant, which is actually an invasive ant, by 2,500 miles. So it was only known from like the East Coast and the area, and then it was found by a kid in San Francisco or somewhere like up there. So that was a really exciting result. So as we were, doing this project and it was interesting, we thought we want to expand the project and we want to know about the food preferences of ants. And so Ant Picnic was actually designed as a project to be used in schools primarily, to teach students about science by doing actual science. And so this was part of a very large project that's called Students Discover. And the Ant Picnic project was actually developed together with teachers. So I think there's a picture. Yes, so here you can see, so this was in 2016. This was Team Ant. These were 3 teachers and my colleague, Deanna Beasley. You can, I actually see in the foreground here, that thing that you see, this is actually the Natural Sciences Museum in Raleigh. This is in Adrian Smith's lab, the ant lab. And what you see in the foreground there is an ant nest. It's actually a trapjaw ant nest that was molded from aluminum. So you fill that into the ant nest so you know what the ant nest looks like, how deep it goes, because and partly actually goes so deep into the ground that we don't even know how far it reaches, which was true for this nest. Like the metal hardened before it reached the bottom. So we actually have no idea how deep those nests actually go. It's very hard to excavate those. I tried. Next one. So yeah, there you see like Team Ant. This is us doing our best ant impressions. Continue. So if you're interested, so we had like a 3-week externship at the museum with those teachers where we were working on Ant Picnic, where we were also creating a data portion for Ant Picnic to be used in schools. And we documented all this with a video. And if you're interested, you can watch that video on one of my websites, on the antlife.com videos. It's also on YouTube. You can probably, there's the link there. It is probably the easiest way to get to it. Go to the next one. So that's just the screenshot. That's what it looks like. So if you're interested, it's a short video and it just kind of documents the teacher's experience at the museum designing these projects. Okay. Okay, so what are the goals of Ant Picnic? So I already said we're interested in what do ants prefer to eat? Why is this interesting? So basically what ants eat or what animals eat at different times of the year in different places tells us potentially what is missing in their environment. So if, for instance, in very water deficient places, the ants are really going for water or for oil or for something very specific that might not be as apparent, that could tell us, what's happening there. And then it's also interesting to look at this over time to maybe see how climate change impacts those populations and what is available for them. Continue. So how are we doing that? We want to identify environmental variables that are potentially connected to food preference. So when you participate in the Ant Picnic project, there's a whole bunch of questions about what is the weather, the day you are setting up the experiment. We also want to know the GPS coordinates because a lot can later be found with the GPS coordinates, like where you're generally located, what the mean temperature is, mean precipitation, and all of those variables. And then we would see how these variables are potentially affected by climate change and how that would impact certain food resources and preference. So who can participate or who are the citizen scientists that are great for Ant Picnic? So for Ant Picnic, this is an easy answer because really anyone can participate. Ant Picnic is great for the classroom, but that doesn't mean that you can only do it in the classroom. It's really set up in a simple way. And as I tell you, the specific steps you'll see. But if you are a teacher, we actually created a teacher guide have it right here. So this teacher guide is available for download. It's available for free. The teacher guide was created together with another fellow, but not a fellow teacher, but another teacher who's who wasn't part of Team Ant. She was part of Team Dinosaur, but she was so into ants at the end of this that she got so excited about it that she wanted to collaborate, and it was great to work with Rachel Palmentier, who has also moved on. I'm not entirely sure where she is now, but if you're interested, you can look at her Twitter account. And yeah, so if you're a teacher, I recommend downloading the teacher guide. Everything I talk about in the next few minutes, you can also find in there. All right, so the research question for Ant Picnic, I already talked about a little bit. So in a nutshell, it's which foods do ants prefer in different environments? How do you participate? So first of all, it's about preparing the baits. So it's a bait experiments. We have 6 different baits that we're testing, and you need a few things that you can basically, most of it you can get in any supermarket. A few of those things are a little bit more complicated, but it's still easy. So what do you need? You need cotton balls. You need a cookie, ideally a pecan sandy, if you can find it, but any shortbread cookie or something like that will do. You need protein powder. So we in particular use L-glutamine powder. That's I guess, the priciest and the most complicated thing, but you will get it at any vitamin shop or something like that. You need water, tap water will do. You need extra virgin olive oil. You need sugar, you need salt, and you need some mixing jars that you can use it. So you may already have seen that the cookie, the protein powder, the water, the oil, the sugar, and the salt, those are our 6 ingredients. Those are our 6 baits. Yes? Okay, how do you prepare the baits? So what do you need to do? Mixing jars and the cotton balls you can set aside. You're going to use the mixing jars to make the solution. So first you need to prepare the 3 bait solutions that need mixing, which are the amino acids, the sugar, and the salt. So I actually didn't put how much of each is in there, but it is in the directions on the SciStarter website. It's on the Ant Picnic website, so you will find it. What's important to think about is with the amino acids, because it's a protein solution, it won't dissolve in the liquid. So it will be basically just a murky substance that you just need to stir up a little bit before you put the cotton ball in there. The sugar will need a warm solution, so it dissolves, and the salt won't. So for that, the olive oil, the water, and the cookie bait don't need any special preparation. The cookie will just be crumbled, and the water and the oil you just need handy. Yes?
Would it be, just want to confirm, so for creating the solutions, this is just tap water in various temperatures, like the sugar would be the warm water, but tap water be fine?
Yes, tap water will be fine. And again, if you're lucky and your sugar somehow dissolves in colder water, or you just warm it up a little, but the goal is basically just to create solutions, like at the mixture that we needed. And so for the sugar and the salt, it'll be a clear liquid when you're done, but for the amino acids, it won't be. So it will be like murky, and you want to stir it before.
All righty.
Okay, so then next what you're going to do is you're going to label index cards, because that's where we're going to place the baits. So you have 6 bait solutions, or you have 6 baits, and so you have 6 index cards. What should be on the index card is the name of the bait, the date, and a group or a name or something. So it depends how you're doing it. I'm hoping that wherever you're doing the experiments, you maybe are not setting up just one experiment, but maybe several, even if you're doing it at home or as a family or something. Then you could just, name each group, each experiment a different name. Or you can just call it group A, group B, group C, or something like that. Okay? Yeah, so I mentioned this. Ideally label the index cards with a pencil. I already said what should be on there. And then there's also the experiment in progress sign. You can just print that out. You're going to label that with the date, with the time, and with some contact information, assuming you're not setting up the experiment in your own yard. You're doing it maybe in a more public place, because there will be a 1 hour wait time. And so if you're leaving the experiment alone, it's a good idea to put some contact information in case somebody has questions, or that people just don't think that they can just destroy it, or it is something, that they see it's something important.
That could also, if you're thinking about this for students or youngsters in general, having a sign like that and being able to put that up as I am doing an experiment. I personally, at my own age of not being a child anymore, think that makes me feel very cool. So
it's usually liked.
Yes.
All right, so now we prepared all the solutions. We have our index cards ready. It's time to set up the baits. So you want to do this on a non-rainy day, ideally a non-windy day, so that things don't get blown away. So ideally a sunny day, of course. If that's not the case, if it is rainy, rain is not ideal, but if it is windy, you have the option to kind of maybe be creative, to think about something that won't blow away the index cards. You can put a little rock on them, maybe, or maybe a thick nail that goes through it, or a stick that just keeps it in place. It's only important that it's not something that will mess with the bait. So it shouldn't be something edible or something that, so it should be something natural that doesn't have a taste or a smell, ideally. You're going to set up the experiment in progress sign. You're going to put out your baits. You're going to do this ideally in a little group or in a circle. Don't put them in a line, because that makes the first bait really far from the last one. And you kind of want the ants to encounter them all at the same time, so that they actually have a choice. Okay? Okay, how does setting up the bait specifically work? So I mentioned the cotton balls at the very beginning. So as you're setting out to your site, you want to have all the solutions with you, and you want to have the cotton balls with you. You also want to have your cookie with you, of course. So you're going to take one cotton ball, soak it in a solution. It doesn't need to be soaking wet, but it should just, be covered in the solution. And then you're going to set it onto the index card with the proper bait name. Then you're going to take the cookie. You're going to take a quarter piece of a pecan sandy. I think I wrote in the instructions, if it's not a pecan sandy, like how big should that piece be? So don't worry if it's not. But you're going to crumble it up and you're going to put it on the index card. Just make sure that it stays on the index card. Okay, then you're going to put them down approximately 1 inch apart in a circle bunch. Oh, I did say line here. This should say not in a line. I'm sorry about that.
I'll fix this.
To confuse everybody further. Okay, so then what you're also going to bring is your data sheet. So this is also something you will find on the websites. This is all like the stuff that you will download beforehand, and on the data sheet you will record your start time. Just the moment you set out your experiment, that's the time you're going to record. And then there's a few more questions that are going to be asked on the data sheet that talk about what the specific spot is where you set up the experiment, what the weather conditions are, and so on. And you're going to then set up the experiment in progress sign. Maybe you're going to, lay it there like on the ground, or maybe you're going to put it on a little stake. Then it looks more official. So you can be creative with that. Okay. Oh yeah, here's the student data sheet, or just, it says student data sheet, but again, this is the data sheet for everybody. So here's the start time at the very top. Emma just circled it. You want to record the outside temperature in degrees Celsius, which is what we use in science. We use the metric system, which is lucky for me because I grew up with it. You're going to circle the weather conditions, again, sunny, partly cloudy. If there's something else, you have the option to write it in there. You want to put down the wind conditions. Again, if it's very windy, that could impact certain things. And then there's some questions about the particular location where you're putting down the experiment. Is it in the shade? Is there anything near that might attract ants? Maybe it's near a trash bin or something like that. And then, this is maybe the most complicated part, you need to put down the latitude and the longitude of your site, so GPS coordinates. You can get them with Google Maps. There's a way to get them. There are instructions, I think, even in the teacher guide. And if not, the internet knows how to get GPS coordinates from Google Maps. But it would be great for this to have a phone out or something like that that can record the GPS coordinates. All right, now comes the time, because you've set up the experiment, and now we wait. And we wait exactly 1 hour. And now the big question is, what are you going to do in this 1 hour? Okay, so there are multiple options. If you have your teacher guide available, there are multiple options to do in there, like in the classroom. So one, which is probably the most fun one, is to find your spirit ant. This is an activity that was also developed around that time. And so we're describing 15 different ant species that are, generally common in the US in general. I mean, this was for the southeastern US, but most of them you can find in other places as well. And we're describing them, or I'm describing them, just kind of in a way that's like relatable to us humans. So you can figure out which of those ants is like you. Yeah, that's the findyourant.com. That's the website. And here you have the 15 different ants.
Do you know what ant you were?
I guess out of these, because I have so many ants, like I designed the activity for Austria as well. And so I used like Austrian ants. And then we also have, if you go to the top of that and look at our ants. So that's actually a little thing that I created for the teachers. And so I made an ant for everybody and described the ant a little bit. And so there's me.
Oh, wait. Where'd you go? Was this? Oh, there you are.
Yeah, that's the trapjaw ant that I found in Borneo, and it was just one. Again, it's like, because trapjaw ants jump with their jaws and they jump backwards, and this ant that I found, in addition to jumping backwards, which is already crazy, also jumps forward. And so I kind of relate to that, because I feel she's trying to do everything, and she's doing neither of those jumps very gracefully, but it's still, she's kind of trying it all. Yeah, there's a leaf cutter ant. Yeah, so that was like my parting gift to our group. Okay, and what you can also do during this time is you can set up additional ant picnic experiments. So you could, for instance, go in a circle if you want to set up, I don't know, 5 or 6 experiments that it might take up exactly this 1 hour time, and you can then go back around and pick them up again.
Excellent.
Okay.
Yeah, for a classroom experience, that would be helpful. Oh, whoops.
All right. So I hope you were listening very carefully about what I was telling you about. And now we're going to check your knowledge if you're ready to be an ant picnic scientist. So how many food types are we testing in the ant picnic experiments?
It just says that FYI, I only give you the answers of A, B, C, or D. So make sure you're confirming with what you're choosing as your answer.
I don't know if I should narrate them.
Narrate the responses or the
yeah. So A is 1, B is 3, C is 4, and D would be 6.
Which one? Oh, we've got some conflict. We're at war between 2 answers. Okay, I'll go ahead and end the poll and we'll see. So which one was correct? Are we talking about C or D?
We have 4 or 6. Maybe I was talking about the ones that need mixing and the ones that don't need mixing. So the correct answer is D. We have 6 ones, and they are water, oil, the two that don't need mixing. Then we have salt, a salt solution, a sugar solution, the protein solution, and the cookie. So 6.
Amazing. Thank you to the winner there. Excellent job. Next question. Oh, whoops. There we go.
All right. So what do you need to do with the quarter piece of cookie when you get to the experiment site? Are you leaving it whole and place it on the index card? Are you crumbling it up and spreading it all around, like on the index card and around the index card? Or are you crumbling it up and making sure that all the crumbs stay on the index card? Those are your 3 options.
I know what I would choose.
Oh, I just realized I can move that box.
Yeah. 2 screens, and they're both full of boxes. I think we have a choice that is a consensus. We have a consensus for letter C.
Oh, that's great, because that is actually the correct answer.
Yes, that's what I was going to say too.
Congrats.
Pat yourselves on the back if that was you. Excellent. All right, next up. Oh,
All right. Yeah, okay. Now there's a question about mixing the solutions. Select all that apply for mixing the 3 solutions. The amino acids, that's the L-glutamine powder, that's the protein, will dissolve in water, warm or cold, creating a clear liquid. The amino acids won't dissolve in water, creating a murky liquid, which needs to be stirred when adding the cotton balls. So about the sugar, sugar will dissolve in cold water. Sugar won't dissolve in cold water, the solution needs to be heated up. Salt will dissolve in cold water. Salt won't dissolve in cold water, the solution needs to be heated up. So you have 3 correct answers here. So for each of the solutions, so you want to choose 3 options here for each of them. There's always one right and one wrong.
This might take a moment for those. Oh, just kidding. Someone's like, yes, I know the answers. Okay. All right. I'm checking your work right now. Whoever you are. Oh, interesting. Okay, I'm gonna wait for, we only have some answers, so I will wait until we have more. Unless they're taking their time, they're like, oh no, now I have to know the difference between, and this like brings me back to early chemistry classes of like, what's the difference between a mixture and a solution? Or
Yeah.
I don't know, you could learn, you could just drop in so many different types of lessons in this. What a great capstone for.
You're not grading this, so don't worry.
I could save the results and judge you all. No, I'm kidding. Just kidding. Okay, interesting. I get to see some of the responses before other people do. I don't know if you get to see that from your angle, Magdalena, but
I actually don't.
You don't? Okay, well, I can already tell you I'm disagreeing with some of these answers, so I'm very curious if I'm right or they're right. Say, it's a test. Also, for anyone who is watching this later, I hope you're doing the start and stop to quiz yourself while you do this. All right, I'm going to end the poll, and I think we have some unsure people, including myself, because now I'm like, wait a second, I'm not sure I agree with that one. All right, so what do you think about these answers?
All right, so first of all, I did talk about the amino acids. Here it says they will dissolve in water. That's what you guys thought, but they actually won't dissolve in water. So they're really going to create a murky liquid, and you need to stir it before you put the cotton ball in there to make sure that the amino acid pieces are on the cotton ball. All right. Sugar will dissolve in cold water. Nobody agreed with this. Sugar won't dissolve in cold water, which is correct. So you want to heat up the solution, or maybe do this beforehand. You can just use warm water or something like that, and then take it out as soon as it's dissolved. And obviously you can take it outside. And salt won't dissolve in cold water is what people chose, but salt actually will dissolve in cold water. So there's your little chemistry lesson right there.
Here are those answers for you too.
So you really just want to worry about, making sure that the sugar dissolves, like maybe, again, warming up or using warm water, and don't forget about the amino acids that they won't dissolve. So you want something that, stirs it around. But I mean, you will notice, because you can try to make it dissolve and it won't. So
regardless of any temperature change too, that's kind of crazy. Interesting. That could be a chemistry lesson all on its own. Why doesn't it dissolve?
All right. So the hour has passed now, and we are returning back to our experiment site. So let's go to the next slide. So now you need to bring several things. So first of all, you're bringing your data sheet back. And the first thing that you're putting down is you're recording the end time, because your experiment has now finished. Ideally, this should be close to an hour. If it's a little bit longer, a little bit shorter, that's what I want you guys to record. So you're also bringing Ziploc bags. You're bringing 6 Ziploc bags, because you will be picking them up, but not just yet. So first, you're going to carefully walk towards your experiment. And it might look like this picture up here, like it might be full of ants. There might also just be 1 or 2, maybe larger ants that are at the bait. So you're going to walk close to it so that you can see all the baits. And then there's something called the pre-collection count. So on your sheet of, on your data collection sheet, you have a pre-collection count option, and there you will put down the numbers of ants that you can see, that you can estimate. So for each of the baits, okay, if I see something like this one here, this is the sugar bait, that's going to be hard to estimate. So don't worry about this too much. You can give your best guess. The idea of the pre-collection count is really if there are just 1 or 2 ants at a bait, and as soon as you come closer, they just disappear. We want to make sure we still record them. That's the idea of the pre-collection count. Yeah, so you're not picking up the baits just yet. You're just observing, you're counting them, and you're recording your end time. Okay, next. All right, here you go. That's the data collection sheet. So right in the top row, you see the pre-collection count. This is before you collect the index card. You will record it for every single bait, and you don't have to count the total ants just yet. Okay. Okay, and now you're still not picking up the baits. The next thing you're doing is you're going to have your phone with you, or some camera, some digital camera maybe, and you will take a picture. So you can do this in 2 different ways. You can either take a picture that gets all the bait cards, like you see at the bottom here, or you take a picture of every bait individually. And there you also actually nicely see what that should look like when you have your cotton balls based on the placed on the index cards. So you're going to take that picture, and you're going to then upload that picture when you upload your data as well. And this is just, to have some visual evidence of what was going on for us as scientists. Okay. Yes. So everything should be clearly visible when you take that picture. Ideally, you should be able to see which bait is which. So make sure that they're visible, and try not to disturb the ants. So don't, like step in the middle of the experiment. Try, carefully if you can take that picture without disturbing the ants. Try to get as close as possible. But again, I did mention that you can take individual pictures, and that you will upload those pictures. Take these pictures even if you don't see any ants. Yeah. Okay. All right. And now is the time that we will collect the experiment. We will collect the ants. Go to the next one. Okay. So you have your 6 Ziploc bags with you, and then you will take 1 index card and place it in 1 Ziploc bag. You don't have to label the Ziplocs, because they're translucent anyways, and you can see, which bait is in there. But make sure you're not placing several into 1 Ziploc bag. So each bait goes into 1 Ziploc bag. You might want to be fast doing this because the ants might run. Don't be scared. Like sometimes people are scared because there's so many ants like roaming around, and people are worried about maybe, getting stung or something like that. But just do it quickly. But yes, I did mention worries about getting stung. So I should have put another poll in here, which says how many of you live in an area that has fire ants, because not everybody has fire ants. Emma, do you have fire ants where you are?
I'm actually not sure. I should know, and I feel like I have heard that yes, but does Phoenix, Arizona have fire ants? Anybody know?
Oh, definitely.
Definitely. Oh, okay. Great.
Yeah. In open areas in the south, in the southeast, you definitely have fire ants. But the further north you go, the colder it gets, you don't see them as much. But when I did this experiment with my teachers in North Carolina, there was a huge concern about fire ants. So for those of you who don't know fire ants are an invasive species. They came from Argentina. They're very successful in disturbed habitats. And they do have a stinger. So some ants have stingers, just like bees and wasps, and you can have an allergic reaction to them. So for my teachers, when they heard about, oh, we're going to like do an ant experiment, their first concern was, well, what if my kids are allergic to fire ants? We can't get near fire ants. So I said, all right, then the first thing we're going to learn is how to identify a fire ant. It's actually not that hard. Let's continue. All right, so now we'll see who of you have ever heard about fire ants, but I put 4 ants here for you, and let's see if any of you guys can guess which one is the fire ant. So I want you guys to like pay a little bit attention to, there's a part between the, the torso of the ant and the backside of the ant that's sometimes like 1 knot, sometimes 2, like a node. So that plays a role. If you've never really like looked at an ant before, this might be complete news to you, but I will, tell you a little bit about that. But if you have never heard of fire ants and you just don't know what they are, then just take your best guess which one could be the fire ant, and then I'll tell you how you can recognize these.
I'm going to go ahead and give you the poll of A, B, C, D. That's 4 options for you. Just relaunch that one. Okay. So A being the first one, B being the second one, C being the third one, and D being the 4th one. Ooh, we're split. I won't lie, I looked at the slides for this one, so I know the answer. So now I'm like, oh, can't answer. Don't give anything away. Although now I'm like taking a look at the different attributes. I'm like, oh, interesting. There's a difference in blah.
You can now see the other ones as well. Like if you already know the answer, you can kind of look at the differences. That's true.
Yeah. Which you will all be able to do momentarily. All right, I'm going to end the poll. One of them is correct.
Okay, yes, we have 1 person correct, but the person that chose A wasn't super incorrect because they at least are in the same subfamily. And this is about like those 2 nodes that they have. Do you guys see that there are like 2 nodes there, right there? Yeah. All right, so let's have a look. So the correct answer was, actually, I think yeah, there's the correct answer. I guess I talked about it beforehand, so you can go back 1 or 2.
So it's these are nodes?
Yeah,
Oh,
they're nodes.
okay.
All right, so so I made like this little graph to just, actually this was really triggered by my work with the teachers and my ant picnic, because this was such an issue. And so I wanted to create something that helps, anybody to recognize, fire ants, because it's important to recognize them if you're in an area where they are a problem. All right, so first of all, fire ants are shiny. So if there's a little bit of sun or something, you can really see that there's some shine to them. Not every ant is shiny. Some ants are dull. They're sometimes very hairy, or they have like a different surface, but fire ants are very shiny. They're kind of a reddish color with a darker abdomen. So their backside is a little bit darker, but fire ants, you can kind of remember the red with the fire. So then I had already mentioned the petiole nodes. So this thing between the torso and the and the backside of the ant is called a petiole. It's actually what makes an ant. So no other insect has a petiole. It's the ant characteristic. And the petiole comes in different shapes and forms and sizes. And one subfamily, the myrmecines, they have 2 petiole nodes. And that's what fire ants are part of, the myrmecines, and that's why they have 2 petiole nodes. So if you remember from the other pictures, there was one ant that had a single petiole node. And there was another one that had like it looked like it didn't have a petiole node. Yeah, there you can kind of see it. So number 3 is a garden ant, and it has 1 petiole node. It actually looks different than the 2 kind of nodes of the other one, almost like a scale. And then number 2, that's actually an odorous house ant or sugar ant. It looks like it doesn't have a petiole, but if you look very carefully, then you will see that it's flat and it's kind of hidden under the abdomen, which is really sneaky and very hard if you need to identify ants. And that's what you're looking for. But I still didn't want to keep that from you guys. Okay. Another thing for fire ants is that they come in different sizes. So if you see a fire ant mound, you will always notice that not all ants are uniform size. There are smaller ones and there are bigger ones. This is actually a really important characteristics because there's not that many ants that show these diversity of sizes. And fire ants, you know, that's not the way you want to recognize them, but it is a way to recognize them. They do have a painful stinger, so you do want to avoid that. So if you do have fire ants and you are worried about them, you know, you can either leave it because you can't pick it up and your health, you know, is more important than this experiment, of course. If there is a way that you can pick it up, you can maybe use gloves or something like that, or maybe forceps or something that you can use to pick it up and put it in the plastic bag. Okay, so now you guys are all ant experts and know how to recognize a fire ant. All right, so now we have all the collected ants in the bags. And what we're going to do now is we're going to go into an inside area or some area where you have like it can be outside, but you want to carefully count the ants in the bags. You're going to keep the bags closed so no ants can escape. If there's a lot of ants, then you could divide the bag into quadrants and count them that way. If there's so many ants and they're like running around the whole time, there is the option to freeze the bags overnight. That obviously slows the ants down. You can also freeze them for a little bit because it will slow them down and they will come back to life afterwards. So that is also an option. If you want to, go to the next slide. Yeah, so you're bringing the ants inside, you're counting, so there's quadrants, I mentioned that. And then to make sure that we get an accurate number, we're going to do 3 separate counts, and those 3 counts should ideally be done by 3 different people. So if you're doing this in school, this is perfect. You know, you have 3 different students, you know, count this, or as a Girl Scout troop or something, you can have 3 different people, you know, count the bag. If you're doing it as a family, then again, divide it up, everybody does a separate count, and then you're going to calculate an average. And that will give us the most accurate number, especially if there's a lot of ants in the bags. If you're worried about what happens with the ants afterwards, you can release the ants back where you found them. Yeah, so you can open the bag, release them. You don't want to release them too far from where you collected them because they're looking for scent trails. And so they want to find their way back to the nest. Okay. Yeah, and that's basically the end of it. So it sounded complicated, but it really wasn't. Now is the time that you're going to enter the data online. Let's go to the next one. So this is where you're going to the SciStarter website. You can find the ant picnic data entry point at scistarter.com/data/ant-picnic. You want to have your data sheet available, and you're just gonna enter all the parts that are on there. Like there's a form, and you're gonna just enter everything on SciStarter. Yeah, that's it. What was the next? Oh yeah, so now I have like a bunch more quiz questions. If you were like paying attention super well to what I was saying, I will know. Okay, So what is the pre-collection count? A, during the 1 hour wait, I need to guess the number of ants I expect to find when I return to the experiment site. B, after 1 hour, I count the number of ants I see at the baits before picking them up. C, after collecting the baits, I eyeball how many ants are in each bag. So which of those, A, B, or C, is the pre-collection count?
Got some smart people online. I would have gone with the same answer, my friend. All right, I'm going to end the poll. Looks like they are correct to me. Answer.
Perfect.
Ta-da!
Everybody listened. Awesome. That's great. That will improve the quality of our data. All right. The next question is, why is the pre-collection count even important? So answer number A is, what's the pre-collection count? I really hope nobody selects that, but that's how you feel. Of course you should. B, it's not, I won't do it. C,
I refuse.
C, it ensures that any ants that might run when cards are picked up are counted. So take your most educated guess.
I love questions like these where it's like, wow, it's written in a way that I can tell what the answer will be. And it looks like our visitors know what
Perfect.
that looks like. Yeah. Awesome. You were right. Excellent job.
Yeah, that's correct. And yeah, I did mention that. So we want to make sure that we get any ants that are, maybe there's just a few of them and they're larger and they will run as soon as you get too close or as soon as you pick up the card. Okay. All right. And now I have a few scenarios and we'll see, you know, what you would choose to do if this happened, you know, when you do the experiment. So scenario number 1. After 1 hour, we return to the experiment and we don't see any ants. What should we do? Answer A, just leave the experiment where it is. No need to pick it up if there are no ants. B, follow all the steps exactly as if you saw ants. Some ants might hide underneath the cards. C, pick up the experiment but combine all bait cards into a single Ziploc bag. D, pick up the experiment but don't record the data. Zeros are not important. What do you think?
Got some mixed feelings about this one. Very mixed feelings about this one. Got answers to every option except for D at this point. I'm going to end that poll so you can see.
Oh, interesting. Okay, so let's go through the answers. So if you don't see any ants at the experiment, those are technically zeros. But there's a difference between numbers and data, and zeros are still data because it tells us that in this location where you set up the experiment, at the time of day, at the temperature, at, you know, what was going on, no ants came to your baits. That's a valuable piece of data. And I do want to get that data. And the second thing is, I mean, you saw it maybe in that one picture. So if you put your cotton ball on the index card, it kind of soaks through. So the oil, like all the watery solutions, they will soak through. That's true that the crumbled cookie won't, but all the others. And there's always an option that there's ants underneath, which you don't see. So the correct answer here is, and you might guess from what I'm now saying, is that you should still follow the experimental procedure as if you saw ants. Because number 1, it's an important data point, even if it's 0. And number 2, there might be ants that you didn't see. So sometimes, I mean, ants can be very small. Don't forget that, larger ants, smaller ants. So I had this before that we've picked up, you know, baits where, you know, the students were like, oh, there's no ants. And then they looked carefully back in school, you know, when they were, or back inside the room where they looked at this carefully and they found that there were 1 or 2 ants that they missed. Okay.
Now I'm going to pause for a second because I didn't realize the time. We're over by 1 minute. So I'm going to go through and just do a quick, we're not going to poll it, but we're just going to read through it. Because I think, yeah. So go ahead. We'll just not do the poll.
Okay.
So we'll be brief with it. Yeah.
Time flies, doesn't it, when you
I
talk
know.
about All right. Second scenarios. Right as we collect the Ziploc bags, the class period ends. There's no more time, or we need to be somewhere. Oh, I said there's no more time twice. What do we do with the bags we collected? Option 1, freeze the bags overnight and count the ants during the next class period or the next day. Leave all bags at room temperature by the window and count the ants during the next class period or the next day. Throw away all the bags. So maybe you might also guess from how I phrased this. I think I mentioned it, that the best thing would be to freeze the bags overnight and count the ants during the next class period. If you leave the bags at room temperature by the window, they might get moldy or something. They won't be happy. So yeah, that won't be ideal.
Yeah.
All right. After 1 hour, we return to the ant picnic experiment just to realize that all the cookie crumbles are gone and some of the cotton balls are missing too. In the distance, we see a raccoon who's the likely culprit. Everyone is upset. What should we do?
Cry.
And it happened before.
Oh no.
So A, just leave everything as it is. The experiment is ruined. B, follow the experiment procedure, but make a note on the data sheet. So when the data is entered, this information can be included. C, collect all index cards into a single bag. So you might already guess from the answer to the previous questions, still follow the experimental procedure. This is still a data point. Make a note on the data sheet so we know what happened and have the information. Okay?
Excellent. Awesome.
Yes. So just to conclude everything, there is, and if you're interested what kind of ants you have, I did create an ant identification key that is available on the Ant Picnic website. That's on the Students Discover website, but there's also on, I think, SciStarter. I'm not sure if the key is directly available from there. You can use that. And I think that was it.
Yeah.
Yeah, that was it. And so if you want to contact me, you can reach me on office@discoverants.com. Discover Ants is my science communication business. If you want to find your ant, your spirit ant, you go to findyourant.com. We looked at the website. If you're interested on about my projects that I mentioned, you can go to theantlife.com and follow me on social media. I would appreciate it.
Awesome. Very cool picture of you in action, looking at ants. Cool. Awesome. I wish we had a ton of time for Q&A because I know I'm just curious about random ant facts. But because we're a little over, I'm just going to go ahead and close this out. Thank you so much for being here, Magdalena. This was awesome. I'm very excited actually to meet you in person in a month or so. So that'll be very exciting. And I've learned so much about ants, and I feel like I'm going to beg all my baby cousins to do this with me so that they become ant scientists and get to realize, or, you know, the adults too, they'd like it too, I bet. Excellent. So I'm going to go through a couple of upcoming things just so you can see what's coming up. World Oceans Day is on the 8th of June. And so to celebrate that, we're going to go over a couple of ocean related projects next week on June 6th. So we look forward to having you there. And we will always have that link to join us on the blog.scistarter.org. You can find all the information there as well. So the second that link is available, you'll be able to sign up, no problem. Lastly, we have a million resources, and on the side of Ant Picnic, on the project page for Ant Picnic, there are so many links that go to resources for students and teachers. I've gone through them as a part of one of our projects with a school district out in Florida. A shout out to Summer, hello, because there's just so many resources to use for this project particularly. So if you are looking to use it in a school or a community, like a youth oriented thing, yeah, and the teacher's guide, it is a super easy one to kind of just jump into. I've also had a library build a take and make kit where they give you all the materials except for like the liquids that are, you know, olive oil maybe I think is what they skipped, because you could just get that from home, or the water, right? So if you are a library interested in making this easier to do as a family over the summer, that's an easy way to do so as well. So I look forward to potentially hearing about the ant picnic experiences if you send any info our way, or send us pictures, honestly, whatever you want to do. That would be amazing. All right, and we have a million resources that you can use to reach out to us if you have any problems, especially info@scistarter.org. And that is about it. So we look forward to seeing you next week, hopefully. And then if you can fill out the survey for us about this event, so we can figure out what we can adjust or make better in the future for you, happy to do so. And it'll also pop up when I end the webinar, I believe. So, or when you leave the webinar. Awesome. Thank you so much, Magdalena, for being here. It was awesome to meet you. This is such interesting stuff about the littlest thing.
Yeah. Thank you so much for having me. This was really fun, and I hope that you guys benefited from it.
Absolutely. If any of the attendees do have questions, I can stay on for another minute anyway, but otherwise you are free to enjoy the rest of your day. We'll see y'all next time. Awesome. Okay, looks like we're in the clear. So I'm gonna send them out. Back, remove. Okay. I wanted to mention, I'm gonna go ahead and close that out. Bye, Facebook. See you later. Move and end recording.